The Geometer Sketchpad is a powerful and exciting new technology for visualizing and investigating geometry dynamically. It's revolutionizing the way that geometry is being taught and learned across the country.
You could label everything, that's what I like about it.
See what happens to the other angles on it.
I like dragging it.
I thought it was going to be hard, but it's not.
Well, geometry is a different kind of mathematics, and it's very abstract. And I found without using the computers and Sketchpad that students had a harder time grasping concepts and applying them. And after using Sketchpad, students with the visual aid, students were able to grasp these concepts that seemed to elude them when we didn't use the computers.
A big part of what mathematics is about is building models that describe the world around you. You're solving a problem, you draw a picture. Well, in a way, that picture is a representation or a model of what you're doing in the real world. Sketchpad lets you draw a picture that has mathematics in it.
Use the tools in Sketchpad's toolbox to construct points, circles, and straight objects. You can think of these tools as an electronic compass and straightedge. Commands in the Construct menu, the Transform menu, and the Measure menu extend Sketchpad's construction and analysis capabilities.
The heart of Sketchpad is dynamic geometry, which is the ability to see things moving, to see geometric shapes move through a variety of configurations. So it's particularly good at letting students see what the relationship between the mathematics they're studying is and the vast sense of spatial understanding and visualization that they bring into the classroom, but which they don't have any mathematical way of thinking about. The most valuable experience comes, I think, when you actually have it in a lab and kids can begin to formulate their conjectures and instantly try it out. Because what you're doing when you're dragging a component is moving through an unlimited number of continuously related examples. So they're no longer seeing just one example, but they're seeing the general case. And that lets them instantly pick out what's important and what's trivial in any set of geometric relationships.
You might start by using Sketchpad as a productivity tool, creating figures and diagrams for tests and worksheets. As you become familiar with the program, you can use it as a demonstration tool. Sketchpad with an overhead projection device can serve as your dynamic chalkboard as you illustrate concepts to students. You can add text and print directly from Sketchpad, or you can cut and paste your figures into another application like a word processing or page layout program. Students working on their own or in pairs in a computer lab can engage in explorations and test their own conjectures. This inquiry can be guided by some specific activity in which students arrive at the same or similar conjectures, or it could be open-ended with students pursuing their own avenues of inquiry. Sketchpad allows you and your students to reach far beyond the mathematics found in books and into surprising and interesting mathematics you may be discovering for the first time.
The program is so versatile, though, in its environment that very soon they leave the standard path that they're following and discover some interesting characteristic of a diagram, something about how a triangle behaves maybe when they move a part of it. It's those sort of moments where they're actually no longer following an instruction sheet, but are thinking for themselves, that we're out to encourage. It turns out that because things are dynamic in Sketchpad, students are naturally drawn to it. It's much more exciting than the images in a geometry textbook can be. And you can turn this excitement into challenges in the classroom. You can challenge them to create a drawing that only behaves in a certain way. And in order to solve that sort of problem, they're going to have to develop all sorts of sophisticated geometric arguments. And they'll have an environment in which they can test their geometric conjectures immediately in an attempt to rise to those challenges you give them.
You've moved them around. One's a translation, one is a rotation.
Right.
And the other is a.
The other is the reflection of the first drawing.
Can you tell me how you did those?
Yes. First, I created the figure, which is.
Here's a typical investigation you might try with Sketchpad. Use the segment tool to draw a triangle. You can display or change the vertices labels using the text tool. If you select a segment in your sketch, you can use the Construct menu to construct a midpoint. This point remains a midpoint even as your figure is dragged. A median is a segment connecting a triangle's vertex to the midpoint of the opposite side. This median will also stay a median as the figure is dragged. Construct another median and the median's point of intersection. The third median seems also to pass through that point of intersection. Is that true for any triangle? Manipulate the figure to test that conjecture. You can see the medians intersect in a single point for any sized or shaped triangle. That special point is called the centroid of the triangle. The centroid divides a triangle's medians in an interesting way. You can measure the distances from a vertex to the centroid and from the centroid to a midpoint. These measures update automatically as the figure changes. Do you notice any relationship between the measures? It appears the longer is always twice the other. You can type your conjecture in the sketch using the text tool. Select the measures and use the calculator to create an expression for the ratio of these measures. The measures appear in a pop-up menu in the center of the calculator. Sure enough, the ratio is 2, and this ratio remains constant even as the measures change. Hands-on investigations like these make students active learners, working as a mathematician does, posing problems, looking for patterns, and making generalizations. Students can also use Sketchpad to create geometric art and to model real-world problems. And Sketchpad's text and multimedia capabilities provide a medium with which students can present their findings, encouraging students to communicate mathematically. Students can begin the process of formulating their own conjectures by writing and then sharing their findings with their classmates.
Opposite segments connecting midpoints have equal measurements or are congruent. Also, the segments, when connected, form a quadrilateral.
They love it. They really love it. In fact, the kids very quickly became much more expert than I am at it. And if I have a problem or a question, I just ask them and they'll figure it out for me. So they're very, very good at that. They love it. It's a change of pace. It gives them a chance to be a little more creative. They get to play with the color and the figures and set it the way they want. And they're willing to go further when it's on the computer than they were paper and pencil because it's not as tedious. It's kind of fun. And on the computer, if you make a mistake, it's real easy to fix. You don't have to go back and erase or color. And when they're doing tessellations, for example, if they don't like the colors they chose the first time, they can go back and change it very quickly. So I think they're inclined to put more effort into it because it's easier to fix if you make an error, and they can save it and work on it another time. And so I think I've seen much more creativity that way. It adds another facet. I think we know that students learn in a lot of different ways, and I find that I will pick up the kids that I have trouble getting the pencil and paper work from. Generally, they just love the Sketchpad, and I can get the work from them there. And I include a lot of writing in my course, and the kids that I can't get to do that writing in the classroom don't even think about having to type the conjecture at the bottom of the activity on the computer. And so I find that it really helps me reach some of those kids that I wouldn't reach if I was only in the classroom.
But in any shape, any quadrilateral, you connect those midpoints. For a four-sided figure, you have a parallelogram. And no matter where you drag it, it will work. So let's try that.
I teach in a downtown urban high school with all kinds of economic levels and ethnic backgrounds and religious beliefs. Even the kids who can't speak English as well can still click and drag. The Vietnamese kids, the Spanish-speaking kids I have, they jam on Sketchpad. Even when the English is tough, maybe in a workbook sense or in a quiz, in a homework, many of the students get a better picture, a different picture. It doesn't replace the hands-on with the compass. It doesn't replace the need to lecture sometimes. It doesn't replace the folding paper examples. But it's a very powerful and dynamic tool that students love to use, that I love to use. Lab days are some of my best days in the week.
Let's look at another example where dynamic geometry and visualization can bring greater understanding to a geometry concept. Use the ray tool to draw a pentagon and one set of exterior angles. What's the sum of these exterior angles? We could measure them all and add the measures, but instead we'll use Sketchpad's dilation tool to shrink the polygon to a single point without changing the angles. When the 5 exterior angles surround a single point, we can see that their sum must be 360. For many students, this visual demonstration will be more memorable, demonstrating as it does why the theorem is true.
They seem to stick with it more often. They don't seem to be as frustrated. They tend to have that intermediate success, which leads to their ultimate goal of completing that assignment or finding that conjecture.
Sketchpad's impact is being felt across the curriculum, with many applications in middle school, traditional and non-traditional geometry classes, even up through graduate research programs that depend on scientific and mathematical visualization. At the secondary level, many teachers find their classes jump-started by Sketchpad and its supplemental materials.
Sketchpad is a program and a package of curriculum, and the curriculum is designed to integrate well with existing secondary level geometry courses.
I have used a lot of technology in a lot of my classes. I have found Sketchpad to be the easiest one to use because of the support materials that you can get that go along with it. When I use technology in my classroom, I want it to be something that is not added on. I want it to replace something that I would have done in a more traditional way. Key has put out a series of books. There's one on exploring geometry, and they now have them on trigonometry and conic sections and perspective drawing, all these different books. And what they are essentially blackline master books that you can take a page out of and run off for the students, and it gives them exactly the activity that you want them to do. It's kind of a, today we're exploring bisecting angles, and it has them go through a construction where they would construct an angle, construct the angle bisector, and they would go through step by step doing this. And then at the end, it would ask them questions. Does this work for every angle? If you drag the angle and make the angle larger, is the measurement of the 2 sections the same? Does it remain congruent and so forth? And so I find that very, very easy for them to use.
All right, I want you to try to drag the figure that remains. Drag point E. Does it stay a parallelogram? Yeah. Okay. Now drag point F. Is it still a parallelogram?
Sketchpad is really wonderful for the sort of discovery and problem solving that are promoted by the NCTM standards. If a teacher is trying to make changes in their classroom, one way is to use dynamic geometry software. And another way is to use hands-on models and building things. And this actually fits in very well with Sketchpad. You can build a physical model of something and then model the model with Sketchpad.
It doesn't take much time to get started using Sketchpad because it works just like other programs on your computer do. We have 2 versions of it, one for the Macintosh, one for Windows. And each version is customized to that platform to work in just the same manner that other programs do on those platforms.
Be sure to look at some of the sample Sketchpad documents that come installed with the program. These cover a wide range of subjects, from explorations in higher math through tie-ins to physics and other sciences, and more exciting examples. In time, you and your students can create complex sketches like these.
It's not a hard program. I find it user-friendly, and so anybody who is just willing to give it a shot, you can learn how to use Geometry Sketchpad. It's an excellent program. Try it out yourself, 15 to 20 minutes, and see how much fun you would have with the Sketchpad, and then just imagine how much fun the children will have.
If I was concerned about being an expert in Sketchpad before I used it, I wouldn't be using it today. I would have lost out on 3 years of students having a better understanding of geometry, of having that light bulb go on more often as something makes sense and comes together for them. I would have missed the relationship between the lab and the actual text I'm using, or the homework assignment, or the examination. The kids are bringing that relationship and understanding to the class. It is being translated. So if I waited to be an expert, I wouldn't be using it today. And I think there's enough students that are experts that we can use as resources and not feel like we have to be the best all the time, and let the students actually shine there.
Now that you've seen a little bit of Sketchpad in action in the classroom, take some time to familiarize yourself with the program. You can use the tutorials or just explore on your own. We think you and your students will enjoy doing and thinking about mathematics in a way you never have before.